In this video, I will be showing you how to identify the region satisfying a set of linear inequalities. Then after that, I will also show you how to identify the inequalities that satisfy a given region. So when you're given three inequalities like this, first of all, you need to consider the inequalities as equations and draw the lines of each of the equations. So this y greater than 5 becomes y equals to 5. This one is considered as y equals 2x plus 1. This is considered as x plus y is equal to 10. So we need to draw the lines. Firstly, line y equal to 5 is a vertical line that goes through 5 on the y-axis. But if it were x equal to 5, it would be a vertical line that goes through 5 on the x-axis. Then for y equals 2x plus 1, you could make a small table, x, y. Choose any two values on the x-axis. Let me choose 2 and 4. 2 and 4. And find their corresponding values of y. Y equals 2x plus 1. So when x is 2, y is 2 times 2, 4 plus 1 is 5. And when x is 4, 2 times 4, 8 plus 1 is 9. So let's plot the points. When x is 2, y is 5. Is there. When x is 4, y is 9. 4 and 9 is there. So the next is to draw the line passing through them. So this is the line. But remember that the length of the line does not matter. So let me just extend it. Then the next is to draw the line x plus y equal to 10. X plus y equals 10. You can also use this same method or use the method of coordinate axis. That is when x is 0, you find y, and when y is 0, you find x. So when x is 0 here, y is obviously 10, and when y is 0, x is obviously 10. So we need to draw the straight line from the point when x is 0, y is 10. That's the point over here. And when y is 0, x is 10. That is it over here. So we draw the straight line from there to this. The next thing left for us to do now is to do the shading. But you might want to do the shading immediately after drawing the line. So, but to do the shading, okay, let me identify these lines. Remember, this one is y is equal to 5. It's important to identify your lines after drawing them. This one is y equals 2x plus 1. And this one is x plus y equals 10. So to do the shading, we use LAGB. LAGB. What this rule says is simply that for less than symbol, less than, shade above, and for greater than, you shade below the line. But this is peculiar to lines that are slanting. That is, either line goes like this or line goes this way. You apply this. Or in other words, for any equation that contains x and y, as you can see here, x and y. So you apply that rule. But if it is x equals a number or y equals a number, that one can easily identify which region is unrequired. Because whatever region we're shading here is the unrequired region. So that the required region will now be written letter R. So let's go this way. Let me begin with y equals to 5. The inequality says y is greater than 5. So looking at it, all the values above 5, 6, 7, 8, 9, 10, 11. So that is the required region. So the lines above y equal to 5 is the required region. So I'm going to shade the unrequired region, and the unrequired region is below the line y equal to 5. So this is the region represented by y greater than 5. So let me use a different color for y equals 2x plus 1. It says less than, shade above. And you can see that this inequality says less than. So I'm going to shade above the line. So this is the region representing y is less than 2x plus 1. Then for x plus y less than 10, again is less than. So that means I'm going, sorry, I'm going to also shade above the line. And this is above the line here. That's above the line. So that means this is the region representing x plus y equal to 10. So it says label your region R. So the region R is this common region, R. With that, you have fully answered this question. Let's see the next question after that. Okay, here's the question. Okay, here we are given 2 lines already. So let's see what the question A says. Question A says write down the solution of the simultaneous equations. 3y equals 2x plus 6, which is this, and 4x plus 3y equals 24, which is this. I'm certain you are very familiar with solving simultaneous linear equations using substitution method and elimination method, but this question is asking us to use this graph to find solution. So the solution to these 2 equations is simply where the 2 lines intersect, the coordinates. So you will see that when x is 3, which is this point, y is 4, which is this point. So that means our answer is just x equal to 3, y equal to 4. And it's just a 1-mark question. But I guess it's just to prepare you for the question B. Show by shading on the grid the region defined by all 5 of the inequalities. So let's check them. Let's check them. We already have x equal to 0. We already have x equal to 0. X equal to 0 is the y-axis, remember. Y equal to 0 is already there, which is the x-axis. X plus y equal to 4. This line is not yet given, so we'll find this line. 3y equal to 2x plus 6. 4x plus 3y equal to 24. So these lines are all given. Only this line is not yet given. So let's find it. So I'm going to draw a small table again, x, y. When x is 1 and when x is 3, let's find the values of y. I'm talking about x plus y equal to 4. When x is 1, y is 3. When x is 3, y is 1. So let's plot the points. When x is 1, y is 3. When x is 3, y is 1. So let's draw the lines. So this is the line. So next is to do the shadings. So like I said earlier, x equal to 0 is the y-axis. So we're looking at the y-axis. And looking at the y-axis, it says x greater than 0. So all the region to my right, or to the right of the y-axis, are all the numbers to that side are greater than 0. So I'm going to shade to the left of the y-axis. This is where I'm shading. So this is the region that represents x x less than 0. Remember, because we are shading unrequired region. Please, let's always remember that we're shading unrequired region. Unrequired region. Okay. Then for y greater than 0, above the x-axis, because the line is y equal to 0 is the x-axis. So above the x-axis is the greater. So I'm going to shade the below. Then for x plus y greater than 4, remember LAGB. And by the way, LAGB is applied only when y is already a positive and y is on the left-hand side. In other words, coefficient of y needs to be positive and y itself needs to be on the left-hand side for you to use this LAGB. So because it says greater than, remember this is the line x plus y equal to 4. This is the line. So for greater than, I'm going to shade below the line. So I'm shading here. Let me use a different color. Okay. So I'm shading here. All right. So for 3y less than 2x plus 6, the line is already given. And because it's less than, I'm going to shade above the line. So I'm shading above this line. Then for 4x plus 3y is less than 24. The line is given already. And again, I'm going to shade above because it's less than. And so I'm going to shade here. So remember that here is also shaded. So don't make the mistake, because any region above is shaded. So label the region R. So you can guess the region that we're looking for. It is this region. The label is R. All right. Now, it's possible to have a question that might ask you to write down the set of points with integral values of x that satisfy the inequalities. Write down the set of the coordinates, the coordinates of the set of points that satisfy the region R. The coordinates of the set of points, with integral values, set of points with integral values of x and y that satisfy the region R. So in that case, all you need to do is to, you can see this is one of the reasons why unrequired region is shaded, so that you can make use of the required region. So let's identify the points that have whole number x and whole number y coordinates. So this is one of the points one can easily see. This is one of the points one can also see. And guess what? This point is also there. Even though it's on the line, remember the line says greater than or equal to. So that means points on the line are included. So this is also the point. This is also included. By the way, this point is also included because x is 0 and y is 4 here. This point is also included. Why I'm including the points on the lines is because all the symbols have equal to. It's either greater than or equal to or less than or equal to. So any point on those lines must be included. Okay, so there are quite a number of them. So probably the question would have been how many points with integral x and y values satisfy the given inequalities. All right. So what you do in that case is now to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are actually 12 points. So that's how to answer questions like that. So let's go to the next one. Now we want to look at how to identify inequalities that satisfy a given region. Now let me go back to this first one. The use of LAGB required that unrequired regions are shaded. Unrequired regions are shaded. That's what LAGB is defining. Now, the rule for identifying the inequalities that satisfy a given region is BLAG. That is the opposite of the LAGB. BLAG. BLAG. And in this case, it's talking about when the region shaded is already required, because that's how you can, like here it says the region R shown shaded in diagram is bounded by 3 straight lines. Write down the 3 inequalities that define the region. So in this case, if below the line is shaded, then use less than. And if above the line is shaded, then use greater than. I don't want this mixed up with LAGB. This is the opposite of LAGB. All right. So let's see. So the horizontal line is for y equal to 6. That one is simple. Looking at y equal to 6, below the line is shaded. So automatically, I'm going to use less than, because we are writing that inequality that satisfy the region shaded. So one of the inequalities already is y is less than or equal to 6, because the line is a solid line, so I have to use less than or equal to. If it were a broken line, I will use only y less than 6. Now for this other line, y equal to x minus 3. You can see that above the line is shaded. So because above the line is shaded, I will use greater than. So the other inequality is y greater than or equal to x minus 3. Okay. So, and then for the third inequality, for third equation rather, x plus y equal to 5. Above it is shaded. And because above is shaded, I will also use what? Use greater than. Therefore, x plus y is greater than or equal to 5. So these are the 3 inequalities that satisfy the region marked R. Let's proceed to the next question, where we will have to find the equation of the line ourselves. This question. Okay. So in this question, only one equation has been given, and we're asked to find the other equations and then identify the 3 inequalities that satisfy the region. So probably I should begin with the one that has been given already. Remember BLAG. Like I said, you use this to find the inequalities, but LAGB is used to find the region shaded. Okay. So again, looking at this line, y equals 1/3 x minus 2. You can see that above it is shaded. That means the inequality is greater than. Therefore, the inequality equivalent to this y equal to 1/3 x minus 2 is y greater than or equal to 1/3 x minus 2. That's the first inequality we're having. Now let's look at the vertical line. You can guess the equation of the vertical line. The vertical line passes through -1 on the x-axis. Therefore, the equation of the vertical line is x is equal to -1. That's the equation. So let's look at the shading. You can see that to the right of -1, or to the right of -1 is shaded. And that means the side greater than -1. Therefore, the inequality for this one this vertical line is x greater or equal to -1. I repeat, BLAG, BLAG talks about the region that is shaded and is used in defining the inequality. Finding the inequalities that represent a given region. Now, lastly, the slant line. To find this equation, first of all, identify any two coordinates on the line, and preferably let the coordinates have whole number x and y values. So it comes very easy to use this point on the coordinate axis, which is when x is 0, y is 4. And when x is 4, y is 0. What do we do next? Let's find the gradient of the line. To find gradient of a line, remember you use y2 minus y1 over x2 minus x1. That's the formula for gradient. Okay, so the x1, let's take this as our x1, y1, and this our x2, y2. So let's find the gradient. So the gradient of the line is 0 minus 4 over 4 minus 0, which of course is -1, as expected. Then remember again that the equation of a line is y equals mx plus c. Therefore, y equals m is -1, x plus c. C is 4. That is the intersect on the y-axis, where the straight line intersects with the y-axis, and that is 4. So this is the equation of the line. So because below the line is shaded, and when below is shaded, you use less than. Therefore, the inequality equivalent to that is y is less than or equal to -x plus 4. Therefore, the three inequalities we're looking for are x greater than or equal to -1, y greater than or equal to 1 over 3 x minus 2, and y is less than or equal to -x plus 4, or 4 minus x if you like. So those are the three inequalities that satisfy the region marked R. So this brings us to the end of the lesson on inequalities region. But very importantly, pay attention to LAGB and BLAG. Like I said earlier, LAGB is for finding the region that satisfies a set of inequalities. And when you are any shading you are doing in that process is the unrequired region is where you are shading, so that the required region remains very clear, and that is where you write your letter R. But BLAG is used in finding the inequalities that satisfy a given region. All right, and that given region that is shaded, usually shaded, the given region is usually shaded. So BLAG works with region that is shaded, while in LAGB you shade unrequired region. So I hope this makes it clear and easy for you to be able to find the required region and find inequalities that satisfy a given region. Thank you.